Hey class, this is lesson 7.3, multiplying powers with the same base. Our objective here is to learn how to multiply powers with the same base. There will be kind of a rule to follow there. So we'll do this vocab quick. All right, so here's the idea. Property is multiplying powers with the same base. When you multiply powers with the same base, you add the exponents. So here's an example. Now notice that you have to have the same base for this to work, because really what we're doing is just tallying how many times we're multiplying by that base. So, and I would rather have you think of it this way than think of a rule for doing this, but just think about this for a second. That 3 tells you you're multiplying by 5 3 times, right? And then let's say we multiply that by 5 to the, say, the 8th power. Well, that 8 tells you you're multiplying by 5 another 8 times. So you can just combine these two things to get the total number of times you're multiplying by 5, which would be 11. So you can see that it makes sense to add the powers when the base is the same. So just a cautionary thing, let's say we have 2 to the third times 3 to the second. There's nothing we can do as far as writing that with a power because our bases are different. So we wouldn't change that at all if we want to write that as a power. So if we, oh, and also think about this. Let's say we have 5 to the third, and we're going to multiply that by, say, 5 to the negative 7. Well, remember the negative exponent means you're really dividing by 5. So we start by multiplying by 5 3 times, and then we divide by 5 7 times. Well, the first 3 times we divide by 5, we're really undoing this and bringing it back to 1. So again, it makes sense to add those because the effect of multiplying by 5 3 times and then dividing by 5 7 times is we're dividing by 5 4 times. And then we're going to write that, to simplify that, we're going to use a positive power. And the way we write 1 divided by 5 4 times is like this. So let's look at these here. Which is it greater than, less than, or equal to? So is 6 to the 5th greater than, less than, or equal to 6 to the 6 minus 4? Well, 6 to the 6 minus 4 is 6 to the 2nd, so that would be greater than. Go ahead and do the rest, and you can just check your answer here. Might think why that's equal, but think about what happens when you multiply by 1 by itself over and over again. So let's look at this these problems here. So we're multiplying by 9 5 times, and then we're multiplying by 9 another 3 times. So we're multiplying by 9 a total of 5 plus 3, or 8 times. And B, we're multiplying by negative 3 negative 2 times, so really we're dividing by negative 3 twice. And then we're multiplying by negative 3 by itself 10 times. So the effect of that is multiplying by negative 3 8 times. All right. So I'm going to pause here, and you can do these problems and check back. One thing I'd like to note on these answers here, if this answer, if you were to simplify that, you would want to write it with a positive exponent. So you would write 1 divided by 0.5, 11 times, like that, if you were simplifying it. All right, so what is the simplified form of each expression here? Here we're going to use some rules to help us. Remember that multiplication is both commutative and associative, which means we can rearrange these. So what I'm going to do is rearrange this product so I have my numbers together, multiplying those, and then I have my bases together. And then I get 6 times 3 is 18, and then I'm going to use that rule, b to the third multiplying by b 3 times, and then dividing by b 8 times is the same as dividing by b 5 times. And the way I would show that is 18, and then b divided by, then divided by b 5 times with this simplified. Okay, here again I want to combine the numbers that aren't variables, so the 4 and the 3, we want to put those together. Then we want to put the same bases together. And so I'm using the associative and the commutative properties to do this. And so I get 12 times, and then I'm going to do my C next because I like them to be in alphabetical order. But if I multiply by C once and then 3 more times, that's C to the 4th power. And think about that. Any number is the same as the number to the 1st power. So we can think of that as C to the 1st. Then you can see you would add 1 plus 3, and then D to the 5th. Okay. I'll pause here, and you can go ahead and see if you can fill in these answers. Okay, here's what you should have. One thing here, I think we're going to call this property we've been using where we, if the bases are the same, we add the exponents. Let's call that the multiplication property of exponents. And so we don't have to write out the whole reason there. All right. We can use this new property to help us multiply numbers when they're in scientific notation. Remember, when you are multiplying, multiplication is both commutative and associative, so we can rearrange this multiplication in a more convenient way. Let's do the 5 times the 6 first, then put our bases of 10 together. So then we can just multiply that, and then just count how many times we're multiplying by 10. So we're multiplying by 10 6 times, and then we're dividing by 10 10 times, so the overall effect is 30 times 10 to the negative 4th, or dividing by 10 4 times. So really we just added those two to get negative 4. And then if both these are in scientific notation, then our answer should be in scientific notation. To be in scientific notation, we need this first number to be greater than or equal to 1 but less than 10. And if we move the decimal over 1 to the left, that means we need to multiply by 10 one more time. So we are going to add 1 to the exponent, and that gives us 10 to the negative 5th. Another way you can think about this is, right now, from 30, we're dividing by 10 4 times. And essentially what that's going to do is move the decimal 4 places to the left. Well, if we moved it to the left 1 time, then we only need to divide 10 3 times to get the same number. All right, I'll pause here and you can try that. All right, so let's use this idea to solve some multiplication problems. The speed of light is about 3 times 10 to the 8 meters per second. How far would a beam of light travel in 8.64 times 10 to the 4th seconds? So this is 1 seconds worth of distance at the speed of light, and we need this many seconds. So this is a multiplication problem, so we need to do 3 times 10 to the 8 times 8.64 times 10 to the 4. And I didn't put in parentheses there because I know multiplication is both commutative and associative, so essentially the parentheses don't matter. So what we're going to do is rearrange it, so we're doing 3 times 8.64 times 10 to the 8 times 10 to the 4. Well, looking at this, we can determine that we are multiplying by 10 a total of 12 times. And then I could just multiply 8 times 6.4, which is 25.92. And then to make sure we can, since both of these are in scientific notation, I need my answer to be in scientific notation. And since 25.92 is greater than 10, it's not. So I'm going to move the decimal over one place to 2.592. And then if I do that, if I move the decimal 1 to the left, in other words, I'm making that number smaller, that means I need to multiply by 10 one more time. So make that 10 to the 13th. All right. Go ahead, you try it here. Check back with the answer. Okay, some of that might have been a little confusing, but if you can, think about my answers and make sense of it. Anyway, if we round to the nearest hundredth, our correct answer is right here. There will be about 6.67 times 10 to the 30th molecules of water. All right. Lesson check. We're going to want to do the 2 times 3 first. Then we're going to add those exponents, and we end up with 6 times 10 to the first, which we would probably just write that as 6n. Okay. Will it always be in scientific notation if you multiply 2 numbers in scientific notation? I don't think so, and this gives us an example. If b is 1.1 and a is 3, then when we multiply 3 times 1.1, we get 3.3. And that is in scientific notation. If b is 2 and a is 3, then when we multiply 2 times 3, we get 6. And that's in scientific notation because both those numbers are greater than or equal to 1 and less than 10. If b is 4 and a is 3, then 4 times 3 is 12. And that number is not in scientific notation. So we're going to say sometimes they will be in scientific notation, but not always. All right. That's the lesson. I'll see you tomorrow.